Dear colleagues, bonjour. The manuscript of the work commented below is available here. The work is long and of a nature that withstands any hurried exposition of its contents. So in what follows, I shall restrict to only a very rapid presentation of some historical specifications on the emergence of the work. These, I hope, might permit not to consider it too out of place to be exposed here, notwithstanding that it proposes a new quantum mechanics, but not in the least an interpretation of the orthodox one. Other informations on my works can be found on my two websites, either the personal one or the Wikipedia website. I give a brief chronology that led to the second quantum mechanics, and I add some comments on the phases. The first phase was a critical analytic one. It began in 1960 and lasted until 1979. It consisted of 3 invalidations and a long reflection on the problem of locality. The invalidation of von Neumann's theorem on impossibility of hidden variables compatible with the formalism of quantum mechanics. This became my PhD thesis, titled Étude du caractère complet de la mécanique quantique, and published as a book by Gauthier Villard in Paris in 1964. The book is prefaced by Louis de Broglie. Followed several years later a study of Wigner's theorem on joint probabilities, that in fact is an invalidation of this theorem also. It has been published in the Foundations of Physics in 1977, and the publication has been proposed by Wigner himself. And finally, in 1979, I have been invited to say my opinion concerning the status of the theorem of Bell on non-locality. This was a beginning of a new period in my thinking. My constructive period began in 1979 with my considerations on the logical and psychological status of the theorem of Bell. At that time, I was already fully aware of the fact that our nowadays physics was pullulating with false absolutes, that it entailed a stringent necessity to relativize, that we needed a minimal realism instead of the naive one. And I was already in possession of first sketches of what I later called a method of relativized conceptualization. In 1994, I constituted a society called Centre pour la synthèse d'une épistémologie formalisée. This worked during 13 years between 1994 up to 2008, when I put it to sleep, and it consisted in a group of exchanges with a very particularly interesting group of thinkers in various domains. In 2002, I was already in possession of the essence of the method of relativized conceptualization, and I published two exposures. The first one in Foundations of Science, and then a second one in a collective book by Kluwer. At that time, in 2006, when the method of relativized conceptualization was already available, my attention turned decidedly towards a specific question of the development of a second quantum mechanics fully acceptable in the sense of this method. However, for some time, I still kept researching a better interpretation of the classical quantum mechanics. Now, with MRC available for me, the main new problem was how could one keep the process of identification and of specification of the modifications to be made inside the current quantum mechanics under some sort of strict control of the meaning and the coherence. During the whole period 2006-209, the study of precisely this problem inside the method of relativized conceptualization led to the first form of the infra-quantum mechanics, IQM. But when IQM is constructed inside MRC, it becomes quite obvious that in order to be able to define acts of measurement of this or that well-definite mechanical quantity assigned to a studied microstate, like position, momentum, kinetic energy, the moment of the momentum, and so on, one needs unavoidably some general model of a microstate. For how could one imagine a way to measure for a microstate that is both unknown and non-perceivable a given sort of mechanical quantity, like, say, the momentum, without having any model in one's mind? And when, moreover, the observable result of any one act of measurement consists of exclusively some signs, some group of signs, points, traces, sounds at a given moment that are registered on or by registering devices. How can one even only assert that what is called a microstate does admit qualifications in terms of the considered mechanical quantity? This first question focuses now attention upon two other distinct questions. Where has de Broglie's model disappeared inside Dirac's quantum mechanics? How does one code in terms of a given value of the measured mechanical quantity the observable signs obtained via one act of measurement? How, but in quite general terms? These questions, finally, made it clear to me that a fully acceptable representation of the microstates cannot be realized by just formal conceptual modifications of QM_HD. Mere interpretation could not do the job. It finally appeared to me that during more than 100 years, a quite notable number of very outstanding physicists have kept trying to represent microstates exclusively via mere extrapolations from the classical physics that deals mostly with directly observable physical entities. which led them to a theory of quantum measurements that is devoid of any physically operational definition of the way in which an only conceived object entity to be studied, like a microstate, can be generated in the precise role of entity to be studied, in which in general it does not pre-exist. And so it follows that what is called one act of measurement on a strictly non-perceivable microstate of some given sort remained also devoid of any physical operational definition. In such conditions, it is natural that an ultraviolet catastrophe appeared, and that postulates were introduced, Bohr, Planck, Einstein, together with Bohr's interdiction of any model. Then later, around 1930, one whole generation after the postulations, arrived de Broglie, and Dirac constructed a new formalism with de Broglie's model in it, but hidden somewhere inside its formalism, where von Neumann moreover stuffed his theory of quantum measurements. This has now to be replaced, not interpreted, but fully replaced, and replaced constructively, and bottom-up, and endowed with an explicit theory of the measurements defined also in physically operational terms, tied with a specified model. In short, I understand finally that a new quantum mechanics is irrepressibly necessary. The previous ones, the théorie ondulatoire, Dirac's formulation, have been just provisional drafts, permitted by the historical state of the problem, that obliged to start from the classical mechanics and to begin by a top-down progression. These drafts have prepared the possibility and now the necessity to reconstruct bottom-up. Meanwhile, in 2013, I obtained a much better representation of the infraquantum mechanics, where it is possible to become clearly aware that in Bell's theorem, the verbally formulated conclusion does not follow from the mathematical established results. In other words, it is not a theorem. In this year, 2019, I publicly submit for estimation the final version of the principles of a second quantum mechanics, denoted QM2. The second quantum mechanics QM2 is developed inside the structure of reference and embedment that I call infraquantum mechanics, and I denote IQM, which in its turn is developed inside the method of relativized conceptualization, MRC. I now just mention that the construction of the second quantum mechanics has generated byproducts that I think are worth being noted and are maybe more important than the second quantum mechanics itself. The first byproduct is a new sort of concept of probability, the factual probability trees of an operation of generation of the studied object entity. The mathematical expression of the probability laws that are involved by this concept are expressed in Hilbert-Dirac terms, in consequence of Glisson's theorem, and they can be associated with also Kolmogorov probability spaces. The second byproduct is that the mentioned new concept of probability leads immediately to the mathematization of the whole method of relativized conceptualization. So we are now in possession of the mathematical epistemology of scientific thinking. Inside the method of relativized conceptualization, one can discern paths that connect to one another any two mutually distinct scientific theories. This entails the possibility of multiple, arbitrarily complex, methodological unifications of the sciences, and even of the sciences and the techniques. Therefrom, there emerges the possibility to realize in a methodological way, individual from the point of view of description, individual goals as well as structures of individual goals that are subjected to a collective meta-goal. So we can now dream to consensually control our evolution. Permit me now to also add what follows. For me, the construction of QM2 has been densely interrupted by big surprises. And each one of these took a long time for being domesticated, understood, explained, and finally made use of. That is why I take the liberty to propose this. First, read the whole work, up to its end, and only after the end, list the residual questions. These I would be happy to learn and to try to answer. I suppose that Dr. Ferensby can find a way for this to be done. I thank you for your attention.